today they're giving us the graphs of the parent function with a transformation, and we have to determine from the graph what we think it is. So on example 2a, what parent function graph will that be?
Absolute.
You know that's absolute value. So you know this is f of x. Get used to writing f of x. We know it's absolute value. And because it's going up 2, what do I need to put? Plus 2. Outside of the parenthesis, or in this case, the absolute value. Very nice. Now, for the next one, it is not drawn the way I asked you to draw it because this is really sloppy. But notice where the vertex is. It's at -2, -1. So how would I show this? F of x is equal to, open parenthesis, help me out, x plus 2, close the parentheses squared, and what does that -1 tell us to do? -1. Awesome. Good job, guys. And the last one, the vertex-ish is here. This also isn't really drawn to scale. I probably should fix my notes. We know this is a cubic, and because it moves to the right 3, I'm going to write this as f of x is equal to, open parenthesis, x minus 3, all of that, and does it move up or down? So I don't need anything there, correct? How y'all doing? Awesome. All right, moving on to reflecting graphs. Notice I have that pattern, over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. Do you think I need you to know this? Yes. Notice if there's a negative on the outside, it reflects over the x-axis. So see how this negative is on the outside here and it reflects over the x-axis? Something new from Algebra 2 to PreCalc is now it's showing us where it's reflecting over the y-axis. And this is where that, God bless you, this is where that funny factor out that negative can come from. So I want you on homework to make sure you're observing what is happening when it's reflecting over the y-axis. Now obviously if it's symmetrical it can't reflect over the y-axis, but a cubic can, okay? So we want to make sure we take note on that. Do we know what an x to the 4th looks like? The function g of x is a transformation of the graph f of x equals x to the 4th. Do you guys know what that looks like? Do you have your TIs out? Get out your TIs, and at the y equals, put an x to the 4th. So I call it the u, because I don't like the u, sorry, University of Miami fans. I call it the u because it does look like a chunky parabola, but it almost looks like the u. Do y'all know what I'm talking about, the u? Yeah. Since this question didn't tell us what to do, let's say that we're going to move left 2, up 2. What would this look like, guys?
X plus 2.
Good, I'm going to write f of x is equal to, open parenthesis, keep going.
X plus 2 close
X.
parenthesis to the 4th.
Nice.
And then plus 2.
Plus 2. Okay. So one of the reasons I have this in here is we're going to start working with harder things like x to the 4th, f of x equals 1 over x, etc., etc., etc. But remember I told you I want you to be aware of what happens with those negatives. So let's look at example 4. We're just comparing with the parent function. We know that the parent function, I'm going to draw it on this first one. We know that the parent function looks like this, correct? This is what the parent function of a square root looks like. What happens if letter A, it tells us negative square root of x? What are we doing? It's reflecting, let's start saying it the proper way. It's reflecting over the x-axis. So it's going to go this way. Okay, this was the parent function. On the Desmos today, they tell us this is the child function. I thought that was kind of funny. I had never heard that. All right, now what happens, again, my parent function's in green. What happens on B?
Over y.
It reflects over the y-axis, right? Voila. Cool? All right. What do you guys know about C? This negative tells me it's reflecting over the x-axis. And because x minus 2 under the radical, is it going up, down, left, or right? Left 2. So I know it's going to go here, and we just heard it's reflecting over what axis? The x-axis. So we have to think. We have to. All right, what about this one? This negative tells me it's doing what?
Reflect over the y-axis.
Not reflect over the y, reflect over the x. Okay, and what does this x minus 1 tell me? It's going to the right one. Now, I do want you to pull out your TI, and I want you to look at this, because this is that confusing one that I told you is going to get you. What happens if I have negative x minus 1 under the radical? I believe, and you could correct me if I'm wrong, we want to look at this like this? Yes? No? Maybe so. So when I graph this, am I going to graph up, down, left, or right? Left. So it's opposite of what I think here. So I'm going to graph here, and because of this negative right here, it's reflecting over what? The y. So instead of going to the right, it should be going to the left. How'd I do? Blank? Thing that we're going to talk about is called non-rigid transformations, and this is talking about shifts. Now, this was really great in my notes when it was color-coded, but it is no longer color-coded. Okay? Horizontal shifts, you know, go what? Left and right. Vertical shifts go up and down, but now we have these when we multiply by 3. We've talked about this, so we should understand it, but I'm going to color-code it for you. The square root of x looks like this that I'm drawing in peach. Do you see that? Okay. When I multiply by 3x, sorry, 3 on the outside of the absolute value of x, remember this is going to make it a little skinnier. Do y'all see how this gets a little skinnier? Okay, and sometimes we get confused on that because when we multiply by 1/3, we think, well, 1/3 of it is going to be skinnier, but what happens with 1/3? It does get a little chunkier, so it's going to be a little wider. Okay, they call these stretches